Okay, so this video is about solving linear equations. And we're going to talk about what that means now. So let's first talk about what an equation is. So, solving linear equations. So by definition, an equation is a statement in which two expressions are equal. A linear equation in one variable is an equation that can be written in the form ax equals to b, where a and b are constants and a is not equal to 0. Constants being numbers like 1, 2, 3, 0.5, 0.6, square root of 7. A number is a solution of an equation if the statement is true when the number is substituted in for the variable. So it's kind of important. A number is true is a solution if the statement is true when that number is plugged in for the variable. Two equations are equivalent meaning equal to each other. Two equations are equivalent if they have the same solutions. For instance, the equation x subtract 4 equals 1 and x equals 5 are equivalent because they both have the number 5 as their only solution. The following transformations or changes produce equivalent equations and can be used to solve equations. And these are those transformations. All right, so one is the addition property of equality. Basically, you can add the same number to both sides of an equation. Like if a equals to b, then a plus c equals to b plus c. So I can add the same number to both sides, and the equation is still true. The subtraction property of equality. Subtraction, you can subtract the same number from both sides, and it still be true. So if a equals to b, then I can say a subtract c equals b subtract c. They both have subtraction of c on both sides, making the equations still equal to each other. There's a multiplication property of equality. Basically, you can multiply both sides of by the same non-zero number. Non-zero being a number that's not 0. If a equals b and c is not equal to 0, then a times c equals to b times c. Always. So that's always true. And the last one is the division property of equality. Divide both sides by the same non-zero number. So if a equals to b and c is not equal to 0, then a divided by c equals to b divided by c. So those are all properties that allow you to solve equations. All right, let's apply that to equations we're going to talk about today. All right, so this is our first linear equation. Linear means it's degree 1. But the equation says 3 over 7x plus 9 equals to 15. So to solve this equation, our job is to isolate the letter x. And then we've solved it. And whatever the number equals, that's what x is. So to begin, we'll first begin isolating the letter x. Isolating the letter x. Right now, the term that x is being multiplied to is here. So I need to get that term alone. So basically, I will move everything away from this term. Right now, there's a 9 on this side of the equation with it. So I want to move the 9. I want to subtract 9 from both sides. And that will give you the equation 3 over 7x equals to 15 subtract 9. 15 subtract 9 should be 6. So we have 3 over 7x equals to 6. To finish solving this equation, what you want to do is divide by the coefficient. The coefficient, or to isolate x, is here. So here's my x, and I still want to isolate it, and now I have a coefficient. That's 3/7. If I divide both sides by 3/7, I should get x alone. So I'm going to write it over here. So if I divide this side by 3/7, so taking that equation, 3/7 x equals to 6. I can divide the left side by 3/7. I can divide the right side by 3/7. Giving me x equals to 6 divided by 3/7. If you plug that into your calculator, you get this. It should be 14. So apparently, our answer, our solution, is 14. Let's check that out to make sure it's true. So given that original statement, I'll put it here in this little box. 3 over 7 x plus 9 equals a 15. If I plug in 14 right here for x, let's see what it becomes. And I'm going to erase some of this other stuff beneath because I need this space. If you need to copy any of this, pause the video, go back and copy any of that. So let's go. 3 over 7 times 14 plus 9 is supposed to equal 15 if the math is right. 3 over 7 gives you 3 times 14 over 7 plus 9. So 3 times 14 divided by 7 that's 6 plus 9. 6 plus 9 is definitely 15. So 15 equals 15. So it's true. So 14 is our solution. Because when I plug 14 back into the original equation, I get a true statement. Let's do another problem. I will copy all this as a note. I'm about to erase the screen. All right, here's a new equation to solve. It says 5n plus 11 equals 7n subtract 9. Now, if I'm going to solve that equation, I want to isolate both of these n's. Right now, they're not really like terms because there's an equal sign between these two. That means I can't add them just as they are. Because they're on different sides of the equal sign. This is on the left side of the equal sign, and the 7 is on the right side of the equal sign. I need to move them both on the same side of the equal sign. So in order to do that, I got to take one of them. Let's take the 7n and move it to the left. To move the 7n across the equal sign, I have to change the sign. I have to subtract 7n. The reason why is, if I subtract 7n, it cancels out the 7n on this side. 7n subtract 7n becomes 0. So it's going to be 0 subtract 9. And then 5n subtract 7n. It's going to be a negative 2n plus the 11. Now, 0 plus anything, 0 subtract 9 is still negative 9. So this means negative 2n plus 11 equals to negative 9. Now, to finish isolating the negative 9, it's finished isolating the x, I need to get this term alone. So to get this term alone, right now is a plus 11 next to it. So I have to subtract the 11. So if I subtract the 11 from both sides, I wind up with negative 2n equals to negative 20. So now the n is almost alone. The only thing is, though, it has a 2 in front of it as its coefficient, and I want it to go away. So I'm going to take this equation, negative 2n equals to negative 20, and I'm going to divide both sides by the coefficient, negative 2. By dividing by its coefficient, it cancels out. So what I mean is, negative 2 divided by negative 2 cancels out to be 1. So it gives you 1n equals to negative 20 over negative 2. So 1n equals a 10. 1n is the same thing as just regular n. So n equals a 10. So my solution there is 10. And that's how you solve that equation. Let's do another. All right, so in this problem, we need to solve this equation. And this equation has variables everywhere. So the first thing you want to do is to begin isolating the variables is to get rid of the parentheses. So I'll distribute 4 into this set of parentheses, and I can distribute negative 2 into its set of parentheses. So the left side becomes 12x subtract 20, and that's going to equal to positive 2x subtract 16. And since negative 6x is not in parentheses, it just comes down. And that should be 16x, because Actually, that's a 16. It didn't have an x next to it. All right, so from there, we're going to start combining like terms. Here, I have a 2x on the side and a negative 6x. And they're both on the same side of the equal sign. So I can combine them. That now becomes negative 4x subtract 16. And on the right side is still 12x subtract 20. All right, so to begin, I want to get all the variables on the same side. So I would add 4x both sides. And then that would be 12x plus 4x is 16x. Subtract 20 equals to negative 16. Now, again, isolating x, I can now add 20. So that gives me 16x equals a 4. I'm going to rewrite that. And if 16x equals a 4, I can divide both sides by the 16. So x is 0.25. And that's it. I will copy that as a note. That's all I have. Good luck. No, it's not even working.